now we're ready to look at a couple of very important formulas, the midpoint formula and the distance formula. Now, first of all, let's just talk about the midpoint formula. Let's suppose, I've plotted some points here. I've got A, B, and C. You can see over here, here's A, B, and C. And I've got their coordinates. Now, let's suppose that I want to find the length of the segment AB. I want to find the length of the segment that starts at A and ends at B. Well, we know how to do that. We said, well, you're going to take 5 minus 1. That's the absolute value of 4, which is 4. So that length is 4. And while I'm at it, let's get the length of BC. Well, now we've got a vertical line, so we just care about the y. So this is going to be 4 minus 1, which equals 3. So this, the horizontal segment is 4 and the vertical segment is 3. Now, if we want to talk about, so that's the length. If we want to talk about the middle point, look at this. On this segment AB, you can see the middle point is right there. Right there. You can just eyeball it and see, because from A you go over 2, and from the midpoint you go over 2 to get to B. So that is the midpoint, and you can just, you don't have to do anything but just look at it, and you can tell what the coordinates are. It's 1, 2, 3, 1. So this point right here is 3, 1. That's what that point is. That's the midpoint. Okay. Now, there's a formula for how we can find that midpoint. What we can do, if we want the midpoint, what we can do is we can average the x's. Okay, let's see how that works. We get the average value of the x's, x1 plus x2, and you get average by dividing by 2. That's going to be the x-coordinate, and then you average the y's. Okay. So in this particular one, let's average the x's. We've got 1 plus 5. We're going to get the average value of the x's, and then the average value of the y's. Okay, so here's what we have. We have 6 over 2 and 2 over 2, and that gives us 3, 1. Yeah, bingo. That's the formula right there. This right here is the midpoint formula. Okay. So that's how you find the average of the x's, the average of the y's, and you got your midpoint. Now we could do the same thing for BC. We know the length here is 3. So here's what we do. For BC, the midpoint would be 5 plus 5 over 2, and then 4 plus 1 over 2. See? You average your x's and you average your y's. That's all there is to it. Okay, so let's see what we get here. We get 10 over 2 and 6 over 2, which is, no, I'm sorry, 5 over 2. Why did I say that? 5 over 2. So here we go. We've got the point 5, comma, 2.5. So let's see here. 1, 2, 2.5 are about right there. Yeah, that's the midpoint. Yeah. So that's how we find the midpoint. It's just a formula. Now, the next formula we want to look at is called the distance formula. And the thing is, I don't want to give you the distance formula without, first of all, showing you where it comes from. And where it comes from is the Pythagorean theorem. So let's take a minute. Let me move this stuff out of the way. Okay, move it down here. The Pythagorean theorem. Now, here's what I have. This blue square here, think about that. I just drew a blue square, and it is a square. It's got the same length and width, right? And then inside what I did was, if you look at this carefully, I started one block down or one grid length down and then went over here to one grid length. So in other words, this line right here, this line, is the same length for all of these. See, so what I've done is I've put a square inside here. See, there's my square. All I've done is I've just made a line segment of equal length all the way around. Okay, I just started here and drew to here, started here and drew to here, and so forth. Okay, now, so I've got a square within a square, because you can see all those line segments are the same. Now let me just label them. Let me label the short sides A. I'll label all these short sides A because it looks like we got 4 triangles in there. Now I'm getting kind of ahead of, we haven't talked about triangles or anything, but that's okay. You've seen them before. So, and then let's label the long sides B. Okay? So I'm talking about these little triangles we have here. You know, we've got A, B, and let's label these C. So I'll label these parts here C. Okay. So this is just like one of those triangles. Okay. Now let's think about, once again, I realize we're getting ahead of where we are in the geometry program, but let's just think about it. Think about the area of this square. Well, it's A plus B, length times width, times A plus B. That's what the area is. Which, if we multiply that out, you know, we get A squared plus AB. I'm just doing a little multiplying, plus another AB, plus B squared. So we get this, we get A squared plus, ooh, there's 2 of these. There, that's the area. That's the area of that whole big square. And you might wonder, well, why did you even put that little pink square inside there? Well, another way that we could talk about the area of this, what's inside this square, this big square, is we could talk about the area of these 4 triangles. See? Let's talk about these areas. The area of a triangle is 1/2 base, which is A, times height. That's the area of each one of these triangles. And there are 4 of them. Okay? So what I've just done is I've calculated the area of each of these little triangles. Oh yeah, I got to put the area of the inside, C squared. Yeah? Yeah. So let's see what we've got here for the area. On the one hand, A squared plus 2AB plus B squared. That is the area. But on the other hand, look at this over here. This right here, 4 times 1/2, that's 2AB plus C squared. Okay, so let's see here what we've got. We've got A squared plus B squared. This and this get rid of each other. Yeah. Now, this right here, this is called Pythagorean theorem. And it just says if you have a right triangle, a triangle with just with a 90-degree angle in it, the side of the hypotenuse, so you have a triangle. And what Pythagorean theorem says is, whoops, that's not a very good one. Okay, let me see if I can draw that line a little straighter. What Pythagorean theorem says is if you have this side is A, this side is B, and this side is C, well, A squared plus B squared equals C squared. That's what it tells us. So the length of B squared plus the length of A squared equals the length of C squared. In other words, C squared equals the square root of A squared plus B squared. Now, that's getting way ahead of where we are. But you've seen this type thing before. So dig this. I've got a triangle here. Okay, I've got a triangle. And I want to know the distance between those 2 points, 1, 1 and 5, 4. Well, we've already concluded that the length down here, okay, is 4. Let me use something darker. Okay, This is 4. That length is 4. And we've concluded that this length is 3. So if we want to know this length right here, we could just say 3 squared plus 4 squared is equal to that length squared. In other words, 9 plus 4 equals c squared. Or in other words, c is equal to the square root, 9 plus 16, I'm sorry. Square root of 25, which is 5. I'm sorry about this mess up down here. This is 16. 9 plus 4 squared is 16. Okay. So that length there is 5. Now remember where we got these numbers. Look at this. Where did I get this 4? Well, 5 minus 1. So look, I could say the distance formula is equal to the square root of 5 minus 1, right, down here, squared, see? 4, that's 4 squared, plus the next one, 4 minus 1, that right there, 4 minus 1 squared. Okay, and the square root. Yeah, see, this is 4 squared plus 3 squared, and that's how we get this. So the distance formula, here's the distance formula. If you want to know the distance between 2 points, let's say you got x1 and x2. I mean, x1 and y1, sorry. And you've got x2 and y2. Let's suppose you want to get the distance between those 2 points. Well, distance equals the square root of the difference of the x's plus a difference of the y's. And that's going to be your distance right there. That's all there is to it. Okay, so let's look at some examples here. Let's suppose I've got a point, P, and let's suppose this is -5, 4. And then I've got Q, which is 2, 3. And I want to find the length of that line segment. I want to find the length of it, okay? So here it goes. In other words, the distance, okay? So PQ is equal to the square root, okay? The difference of the x's, 2 minus -5 squared. See, before we just did the absolute value because we just had one direction, okay? Y stayed constant or x stayed constant. You know, we either had a horizontal or vertical line, but now we have a slanted line, okay? So, and now a difference of the y's. So this is going to be, instead of 2 minus a -5, it's 3 minus 4 squared. And this is going to be the length of that segment. So it's going to be 7 squared. Well, let's do this. 7 squared, right? 2 plus 5 plus -1 squared. So that's the square root of 49 plus 1, which is the square root of 50. Now, if I want to talk about the midpoint of these two segments, the midpoint, okay, well, that's going to be the average of the x's. Add them and divide by 2, and the average of the y's. And this is going to be your midpoint. So this is -3 over 2, and this is going to be 7 over 2. Yeah, so there's your midpoint. Now, the thing is, let's just suppose, so while we're talking about this midpoint thing and all, let's suppose that we have a segment. And let's suppose that, you know, let's do this. Let me make this a length. Let's suppose 1, 2, 3, 4, 5. One more, 6. Okay. So let's suppose that you have a point over here, A, and you have a point over here, B, and here you have a point in the middle. Okay. Now don't pay any attention to how how long this is. I'm just using these little grids so that I'll get the same length. Don't think that that is 3 or anything. So let's think about this. Let's suppose that this over here is 2x plus 1. And this over here is, let's say 5x minus 4. And let's suppose that let's suppose that this right here is the midpoint. In other words, let's suppose that AC is equal to BC. Let's suppose that's the case. Well, how would we work a problem like this? How would we find x? Well, we know that C is the midpoint, so that means that 2x plus 1 equals 5x plus 4. Okay, so let's see what this is. Let's solve this equation. Bring the x's together, and you've got 3x plus 4 equals 1. And then you subtract the 4, so you get negative 3 equals 3x. And then you divide, and you get x equals negative 1. Okay, so if this is true, if segment AC is equal to BC, these are the same length, then x must equal to negative 1. Yeah, so sometimes you'll see problems like that.